In this video, I'm going to give you a fairly comprehensive list of reasons why your print might be stringing, and as much as I can, I'm going to tell you what to do about it. If I posted this photo online in any forum and asked, why is my print stringing, then I reckon I would get at least 10 answers back, and they would all be different. This is one of the fundamental problems with the state of 3D printing at the moment, and let me be clear, I don't think it's anybody's fault. There are just too many variables with current machines and slicers, and many of those variables even interact with each other. Those of us like myself, who are basically tinkerers, we may enjoy this, but it's quite understandable that it might drive you literally mad when you're trying to fix something, but you get a whole list of seemingly unrelated suggestions instead. So, for this video, I've compiled a list, or rather a set of flows, of possible reasons why your prints might be stringing, and I've tried to give an indication of how you can check the most likely or easiest to fix first. I know that flowcharts aren't the most interesting thing in the world, so I've spiced it up with a smiley face. There we go. Sorted. Seriously though, I've marked each section in the timeline, so if you're looking for a specific part, then you can skip straight to it. Without further ado, let's begin. From this top level diagram, we should look at filament first. Notice that I've highlighted moisture and temperature as the first to check. As a rule, wet filament will show other signs of moisture, but perhaps not at first, or perhaps not always. Things to look out for as well are scruffy prints, warts on the external walls, and in extreme cases you may hear popping noises or even see literal bubbles at the nozzle. Another thing I see mentioned is that wet filament, specifically PLA, will snap rather than bending. I think this is a metric to take with a huge pinch of salt, as all PLA filaments have different ingredients, and for example this Eolast filament, it's perfectly dry and serviceable, but it snaps fairly easily. It's a great filament too, by the way, and it's food safe, caveats notwithstanding. In terms of how to fix wet filament, luckily it's generally a reversible process, so putting it in a dryer or a sealed container with lots of desiccant should do the job. The easiest diagnosis here is, you guessed it, try another filament. Try one that's been sealed, that's new, so you can get a good comparison. Temperature next is equally important, as nearly all filaments will be stringy at certain temperatures. This one is a double-edged sword too, as it can cause confusion, because you can get stringing at both a high temperature, because the filament is too runny, but also you can get stringing at a low temperature, which I'll cover in a moment. But the solution to both of these problems is the same, and that is that if you think it's anything to do with temperature, or even if not, print a temperature tower. Now, switching from PLA to TPU and trying to print with the same G-code on an SD card, for example, without making changes in your slicer settings is a surefire way to get stringing. Sure, it might work, but it most likely won't. Click the link here for my TPU video. You should probably watch that anyway. It's had way more views than anything else on the channel. Apparently it's very helpful. I know. Retraction is a bit of a nightmare with TPU. I mean, people are still arguing over whether you even should have retraction or not. Spoiler, you should, in my opinion. Again, see the video linked. It covers all this and more. Finally, cheap filament. Seriously, cheap filament these days is normally pretty good. I print with some of the cheapest filaments you can buy, and I have no issues with filament quality. But of course, if you're buying no-brand stuff that's been kicking around in a non-airtight or dusty environment, or is inconsistent from one reel to another, which is something I've seen with cheap non-branded stuff that doesn't come straight from a factory, then yes, you can see issues with stringing. The solution here is find a cheap brand that you get on with and stick to that brand. I did a video on which brands I use, hopefully that should be linked now. Next up, slicer issues. This is a total can of worms. There's no other way to explain this can of worms. Assuming you're using Cura, which I think is the most popular slicer at the moment, but I've not seen statistics. Assuming that you're using Cura, then at the time of making this video, Cura has no less than 496 separate settings available to the user, whether you like it or not. And that's not including printer settings or material settings. So you can imagine how many of those settings might have a positive or negative or negligible effect on stringing, and how would you know which is which? Honestly, it's no wonder people feel overwhelmed with the settings in the slicer, and while someone like myself who spent a lot of time and effort learning these settings, yes, all 496 of them, I don't think it's reasonable to expect that to be a prerequisite before you are able to print anything. Retraction settings are usually the main culprit in the slicer when it comes to stringing. There's 19 settings for retraction, but the main one is just to make sure it's on. And if in doubt, and this doesn't just apply to retraction, but slicer settings in general, if you aren't getting any joy with your print, then try a default profile. Most of the default profiles that come with Cura, especially if your printer is supported, they do a decent enough job. It might not be optimized, but usually you'll get a reasonable output. In terms of diagnosing stringing, it does also help to have a known model that's already sliced and saved as G-code to test. Most printers come with this on the SD card. For example, the cat is a common model. However, the cat is not great for testing stringing. Because of the geometry involved in the cat, it has no jumps. So having your own test model for stringing on a G-code on a card and you know that it works will help you differentiate between something wrong with the slicer and something wrong with something else, if you get what I mean. So cooling is an important one from a slicer point of view, in as much as that you generally need to use it, and not having it or not having it turned up enough or not turning it on at all will undoubtedly create strings. The only thing I will say about that is that you generally are advised to have it off for the first layer at least to get good adhesion to the bed. Combing and coasting are two often overlooked settings available in Cura. I don't think they're available in Prusa Slicer. I'm not sure about other slicers. Combing tries to restrict the nozzle to inside the part and should almost always be on for good results, while coasting is more controversial and tries to use the filament that would make a string before it jumps by stopping the flow a bit early, if you get what I mean. This should be used with caution, as I've had some unintended holes in prints, especially miniatures, when I've had this setting on. Again, a special mention to TPU at this point, because slicer settings do need to be changed. As I mentioned before, same answer, check out the video. A note about diagnosing slicer settings before we move on. It is imperative that you approach this in a methodical manner. That is the one piece of advice in this whole video that is more important than anything else. Methodical manner. If you change 9 settings and try to print again, don't be surprised if you have no idea which setting affected your output. Using small pieces or calibration towers to test settings is really worth it. Even if it might seem like a waste of time or filament, it probably isn't, because for example, this retraction test here is 12 centimeters of filament, which is almost nothing, and it takes 8 minutes to process. You'll learn more from printing things like this out, and you'll get less frustrated in the long run by being methodical and keeping notes as well, something I do, and organising profiles with sensible names. Hardware is the next area. Unless there's something seriously wrong with your printer, it's usually down to a worn nozzle or blockage issue if hardware is causing stringing, at least in my experience. With regards to the worn nozzle, you will see a general degradation in your print quality along with this, and this will happen over time. You may or may not spot it because things that happen over time you might sort of not see coming. Do you see what I mean? Because it's slowly. But visual inspection of the nozzle is usually the best indicator normally. You should note that the nozzle can actually still look okay until you compare it with a new one, and then you'll notice how much it's been literally filed down in comparison. The tip will be actually physically shorter. Next up, the blockage idea. This is an interesting one. In fact, it's the most interesting one. I actually simulated this here to demonstrate, just to prove that it's a thing. This relates to pressure. If your filament isn't flowing as it needs to because of a partial blockage, the extruder is pushing more filament than the nozzle is able to let out. And so you get excess pressure, but you also get under extrusion. Then when the retraction finally happens for the head to move to another part or another part of the model, there's still pressure in the nozzle and the hot end, and you will get stringing. If you have both stringing and under extrusion at the same time on a print out of the blue that you didn't experience before, then you almost certainly need to consider that you probably have a blocked nozzle. In terms of a solution, often it's as simple as raising the temperature a bit. And as a side note, in order to reproduce this as you see, I lowered the temperature until it happened. Cooling can be an issue if you're using older hardware or a cheaper printer. Modern printers don't tend to have so much problem, I don't think, normally. Of course, your fan can actually just malfunction, it can stop working, it can break. In the situation of poor cooling, your prints will tend to have a melted vibe as well as stringing. I'm sure you know what I mean, they just look like they're melted. A slipping extruder also relates back to pressure. This is something you definitely see more on TPU. In fact, you're very likely to see it on TPU at some point. The solution here is generally to slow down, but also you may have but not be aware of a screw on the extruder that tightens up the tension that it's holding the filament in with. I covered all this in my video. I don't want to push the video again, but go watch the video. Also, don't forget to check that all your PTFE line is secure. If those little pneumatic connectors are loose on either end, then this causes stringing as retractions do not work properly. The whole tube retracts instead of the filament inside the tube. These clips are not 100% necessary. Some printers don't have them, but they definitely do help, and I'd recommend them. And if your printer comes without them or you've lost them, you can actually print some anyway. Finally, and this is kind of a if all else fails section, some models like this Pikachu here are just prone to stringing because of the design, and if you're trying to print something like this and nothing else is working, then maybe try these solutions. If, for example, you rotate a model to such an angle that there's no travel between critical parts, then this will eliminate the stringing because there is literally no jumping. Also, when positioning a model, it helps to look at the preview in Cura before you print with the travel showing. You can get a good idea of where stringing will occur. You could also print a part in multiple pieces and glue it together. Sounds obvious, but you know, it could be a last resort. Or perhaps if you're printing multiple objects in one go on purpose on the bed, just print them one at a time. You can also cut things up. A program such as Mesh Mixer will support cutting things up. Not something I'm particularly familiar with, but I know that it's possible. So to finish up this video, I want to ask two things. Firstly, I want to know if there's anything else you have to add. This video is absolutely a first draft, and it contains my experience only. So if there's enough extra information to add to these slides, please put anything in the comments. Secondly, if this was helpful and you would like to see this approach again for any other specific problem or area, for example, maybe adhesion, extrusion issues, poor print detail, anything really, again, please put it in the comments for me to see whether I can do it. That's it for this video though. Look out for my next one, and remember to subscribe if you like this kind of thing. Thank you for watching.